Let's talk reflection and refraction. So, this week we're going to cover both, but we're going to split it up. So, today we're going to focus only on reflection, which you are going to definitely enjoy because there is no math, no formulas, just thinking about what's going on. So, when we talk about reflection, there are two types of reflection that we're going to talk about. The first is regular reflection, like if you have a mirror in your room and you have a mirror on your wall or a mirror in the bathroom or a mirror in your bag to check yourself throughout the day, wherever your mirror is. You're not going to use a mirror that's going to make you look distorted, right? You want a mirror that makes you look how you are so you can see the way that you look. So that's regular reflection, where you have a mirror, which is represented by this rectangle on the screen. And what happens is we have to always consider where your equilibrium is or where your reference point is. So the first thing that we talk about is something that's called the incident ray. An incident means that it's coming into your object or into your mirror or into your piece of glass, whatever is going to be creating that reflection for you. So this is an incident ray, and this ray comes in at a certain angle. And obviously, you have this reflection that's going to be reflected back, and that's going to produce the ray of light that you see. In order to talk about that, like I said, we have to consider where our normal or our reference point is, and that is what we call the normal. So every time that you do these situations or these problems, you always have to make sure you reference the normal. Sometimes it will be given to you, like drawn on your picture. Sometimes it won't be. Sometimes all you're given is the incident ray, and you have to then yourself draw in the normal. Even if it is a multiple choice question, you are always drawing the normal line in. So the first thing you do before you do anything is make sure you look to see where the normal is. So this is what your normal looks like. And this angle here, this theta with the little I, is called your incident angle. So theta, incident, the incident angle of reflection. The reflected ray comes out from the barrier between where your normal, your incident ray, and your surface is. It comes out at the same exact angle as the ray came in. And this is called the law of reflection, such that you have your incident angle always equal to your reflected angle. Always. The thing to also note for this, the only angle that we care about is the angle between the incident ray and the normal line. Only this angle here. And of course the reflected angle. But the incident angle is only this one. So if you're given a situation and they talk about this angle, the angle between the incident and your surface, well, that angle doesn't have any bearing on what the reflected ray is. So all we care about is the incident angle. The normal line and your surface create a 90-degree angle. They're perpendicular to each other. So your incident angle plus this extra piece down here is equal to 90 degrees. But your theta I is always equal to theta R. The other type of reflection we have is diffuse reflection. And this, obviously, this kind of looks like an iceberg or something, or possibly a piece of glass that fell and shattered and now is on the floor. When we're talking about reflection, we're not only talking about we're not necessarily talking about a mirror that you're able to like look and see yourself. That has a little bit of different properties, but we're talking about just objects that are able to produce a reflected ray. We could talk about all different kinds of situations, all different kinds of surfaces, which we'll get a little bit more into when we talk about refraction. But reflection itself, every material that we're going to be talking about will be able to produce a reflected ray. We're not going to be talking about a situation where you are not going to have any ability to have reflection. So you'll always have some reflection. But this diffuse reflection, to diffuse means to spread out. So when we're talking about this, you always are going with your surface. And if you look here, you have multiple surfaces you could be talking about. You could be talking about this one on the left, and then it kind of curves down, and then it goes up, and then it goes down, and then it goes up, and then it goes down. So you have all of these different surfaces, and each one of those surfaces will have their own normal line and will have their own angle of incidences as well as their own angle of reflections. So when your rays come in, obviously, if they're coming from like a light in your room or the sun or wherever it's coming from, it's always going to be directed in the same situation. However, all of these surfaces, like I said, have different normal lines, different angles that we're talking about. So when these are reflected, they create this crazy looking pattern. But if you look at each one individually, this little piece on the left, you have a perfect reflected situation. Same thing as you move forward. So if you look at each one individually, for that particular surface and the angle that it has, it looks correct. But when you put them all together, obviously it's this big diffused, irregularly shaped pattern.